morning children. In the last class we have come across what's a generator, on what principle it works. Now let us see the construction and the working of an AC generator. What's a generator? It is a device which converts mechanical energy into electrical energy. On what principle it works? It works on the principle of electromagnetic induction. There are two types of generators, AC generator and DC generator. What's the difference between AC generator and DC generator? AC generator makes use of full copper rings, whereas DC generator makes use of split rings. So the current what we get will be the direct current, whereas AC generator what we get the current, it is alternating current. What are the sources of alternating current? From which source we are getting the alternating current? The sources are hydroelectric power plant, thermal power plant, AC generators. These are all the sources of AC, alternating current. Now let us see the AC generator. What actually it consists of? It consists of, you can see here, rectangular coil of wire placed between the poles of a magnet. Ends of the coil are connected to the two rings, two full rings, and inside these rings are insulated. The rings are attached to the axle, and two brushes, you can see B1 and B2, are pressed against the two rings, and in turn the brushes are connected to the galvanometer. Very easy children to say about the construction. Once again I will repeat. It consists of rectangular coil of wire placed between the poles of a magnet. Ends of the wire are connected to the two copper rings, and these two copper rings are mounted on axle, and inner side of these rings are insulated. These rings are pressed against the carbon brushes, and these brushes in turn it is connected to the galvanometer. As we know that when a coil is rotated placed between the magnetic field, current is induced in the coil. So the current is induced in the coil. Why? The answer was given by Michael Faraday. I have explained you in the last class itself. Because the magnetic field changes, the magnetic field linked with the coil changes, and thereby current is induced in the coil. That's what we are going to see here. When the coil is rotated, when we rotate the coil placed between the magnetic field, what happens? Current is induced in the coil. Same thing we are going to see now. Now what happens? The working. Hope you have understood the construction. Now let me go for the working. Now when the coil is rotated, when the rectangular coil is rotated in the clockwise direction, what happens? Placed in between the magnetic field, current is induced in the coil. The direction of the induced current can be found using which rule? Fleming's right hand rule. By applying Fleming's right hand rule, we come to know that the current flows along the direction ABCD, and in the external circuit from B2 to B1. So AB will move down and CD comes up. During the second half rotation, again the current is induced along the direction DCBA, but in the external circuit the current flows along the direction B1 to B2. First time the current was flowing in the external circuit from B2 to B1. During the second half rotation, the current flows in the external circuit from B1 to B2. The current is changing its direction. Therefore, the current is called as alternating current. The direction of the current, the polarity, it is changing. Therefore, the current produced is called as alternating current, and the generator is called as AC generator. And the current we receive at home, our industries, all are alternating currents only. This alternating current is more preferable than DC current because it can be transmitted over long distances. Not only that, its frequency is 50 Hz. The frequency of alternating current is 50 Hz, and it can be transmitted over long distances. Therefore, it is more preferable than what is called as direct current. You got it, children? Now I will send a link for you all. you can see the working in a 3D way also. Got it? Thank you children.